Thank you for joining today's webinar about digital transformation. Today we are broadcasting from New York City and Chicago, and we'll be talking about IoT, predictive maintenance, ERP technologies, augmented reality, virtual reality, and some other subjects related to digital transformation. We put together a great panel for you. My name is Kevin Devecioglu. I'm the Managing Director of Bimser International, and I'm the moderator of today's webinar. Thank you very much for joining. Appreciate it. Today with me there is Brianna Garcia from Tembu, and she'll be talking about IoT systems and IoT technologies in the scope of digital transformation. Also, we have today Sam Watt. He is pre-sales software engineer of Bimser International, and he'll be talking about predictive maintenance and how to practice predictive maintenance operations in the scope of digital transformation. Also, today we have Umut Altınay from ETG Consulting, and Umut will be talking about Microsoft Dynamics ERP technologies, again, in the scope of digital transformation. Next, we have Ali Hantal from VR Masters, and as we all know, VR and AR technologies are very popular, and Ali will be talking about, in the scope of digital transformation, how we can all use AR and VR technologies, how we can adapt, basically, in different businesses. As we all know, digital transformation is also a very popular subject nowadays, and it is simply adapting technologies to benefit from the opportunities that digital technologies actually bring to our world, simply. And in business, simply, we all need to adapt to these technologies to be more competitive, and that is the key. So today will be very practical. We have many things to talk about, and we have limited time. Each panelist we have, they have simply 15 minutes to talk about subjects that they are specialized in. So as you see on the screen, we also put our contact information, our email addresses. So after this webinar, if you like to continue this conversation, if you have questions, and if you like to have special meetings, feel free to reach out to us and send us an email, please. And also some ground rules for our webinar. Please keep your microphone muted. If you have any questions, you can type in the chat box. At the end of this webinar, we have a Q&A session. And during the Q&A session, we'll be addressing your questions. So feel free to type your questions anytime on the chat box, and we keep the microphones muted for all of us to have a great webinar experience. Great. So before further ado, I'd like to hand it over to Brianna Garcia from Tembu, and Brianna will basically talk about industrial IoT systems, remote monitoring, in the scope of digital transformation. Brianna, would you like to take it from here?
Yes, thank you, Kevin, and hello, everybody logging in. So I'm going to go ahead and share my screen. There we go. And we'll jump into the Internet of Things.
Looks great. Thank you.
Yeah. So as mentioned, I am with an industrial Internet of Things software company here in New York City. And we basically specialize in smart connected systems and how anybody, despite any educational and or economic background, can essentially tap into this wonderful wave of Internet of Things connected systems for their own use. So we're going to be discussing digital transformations in the lens of manufacturing for what people usually term as Industry 4.0. This is usually a hot ticket word, but it basically refers to the concept of factories in which machines are augmented with wireless connectivity and sensors connected to a system that can essentially visualize the entire production line, control, and make decisions on its own. So what makes Industry 4.0 efforts so hard? Well, these industrial innovation projects are difficult to put in place for many reasons, which we'll get into, but typically, the technology isn't the actual hurdle. It's ultimately what kind of funds these projects and who is able to essentially lead these projects, because there's a lot of collaboration from many different stakeholders, either inside the organization or outside. And it's not always clear who's in charge and how these things should be paid for. So these are just some reasons why Industry 4.0 is difficult, but we'll get into how we can kind of get over those things. So let's jump into it. How can we make innovation projects faster, cheaper, and more accessible? Well, at Tamboo, we help make these projects happen not only through the lens of our software and technology, but also through how we can approach and how we think about these projects. So I'll show you how we're actually making this Industry 4.0. Again, this is encompassing the digital transformation to achieve connected sensors and systems with the Internet of Things through basically our platform called Kosmos. Kosmos is, well, here's an image of our Kosmos on a desktop, on a tablet, and on your cell phone. So the again, the ultimate goal of this work is to democratize the Internet of Things. And basically what we've created is an application that allows you to create an IoT system in minutes with no coding whatsoever. I am not an engineer, and I can set up an entire connected system within about 30 minutes. And we do it quite often here in New York and around the world, which we'll get into in a little bit. But we've essentially designed Cosmos this way because it's very advantageous for different businesses to work with their existing assets to kind of solve hard problems and use Cosmos or the Internet of Things to essentially start to track and monitor, remotely monitor, and predict when things will happen. So basically we've done is we've specialized in acquiring data from the physical world. We make data accessibility easier through the browsers that you see on the screen. And we also give you the power to have alerts triggered based on application-specific logic. So if you, for example, want to be notified or have an alarm set when a machine is exceeding a temperature of which you know it will malfunction, you can set those results in or alerts in the applications itself, and you can be notified immediately. And as Kevin alluded to earlier, we also specialize in machine learning for predictive maintenance. And we'll get into this in a little bit, but basically what we do is we collect enough data, which is usually about 100,000 data points from a couple different variables, and we can start to figure out with the machine learning algorithm any anomalies, irregular patterns, something that might indicate, okay, this machine based on the past 3 months is going to break in 4 weeks. And now you're starting to get insight as to, okay, great, I can figure out what piece needs to be purchased and start to figure out time and subcontractor schedules to essentially get this item fixed before it actually goes down. So there are a couple ways that we can essentially collect data from the physical world. One is through environmental sensors. So these sensors can be anything from temperature and humidity sensors that are either placed in refrigerators and or freezers. We could also use sensors on existing infrastructure. So we can also use AC current sensors if you want to look at, let's say, HVAC systems, or if you want to figure out the temperature and vibration of a machine and our motor, you can also use those sensors on assets itself. And then you can also access machines' existing sensor data. And this is usually in the form of programmable logic controllers, which we'll get into in just a moment, and or SCADA systems. So if you are a machine-to-machine environment and or already have a system in place, that data is already being logged and stored somewhere. What we can do through our API integrations is essentially extract the information, run some sort of analysis, and then provide it back to you on the Cosmos platform, or send it back to you on your existing platforms.
Brianna, are you with us?
Hello?
Okay, yes, we can hear you now. Okay, great. Welcome back. Please.
Okay.
Looks good.
Sounds great.
Thank you.
So, yeah, that's great. I'm not sure I lost you, but we can collect physical data for environmental sensors, sensors that go on existing assets like programmable logic controllers, or getting data from existing platforms such as SCADA systems and or already stored information from within a factory of some sort. So as mentioned, we are an internet-based software company, and we are hardware agnostic, which means we really don't care what kind of piece of machine you have on the floor. As long as it's functioning, there's a good chance that we will be able to work with it. And so this is a great way to bring more people into the picture and essentially reduce the barrier of entry of using this new technology. And again, we've designed this because it's more flexibility. So there are a lot of companies that actually build the hardware and software components together. And it's good for ease of use, but it's really bad flexibility and for working with people that do not necessarily have the engineering skills to tap into this hardware software component. So we aim to bring the fully integrated user experience to a wide range of hardware devices, which is what you see right here. So as mentioned, programmable logic controllers are usually on manufacturing floors. They're using a variety of different use cases. A lot of utilities, food manufacturing, aviation, et cetera, all have these PLCs, or programmable logic controllers. We also support off-the-shelf environmental sensors. So as you see under COTS, we have temperature and humidity sensors and AC current sensors. These sensors are phenomenal if you just want to collect information without having to actually kind of get into the nitty-gritty aspects of the PLC or programmable logic controllers. And these off-the-shelf sensors essentially come off 5 to 7 years off batteries, depending on how many frequency data uploads you'd like. And then we also support Bluetooth. So the same way people have the AirBuds and or Bluetooth headphones is the same exact communication protocol. And we also support smart switches, which are your remote control features. And then lastly, we support these microcontrollers, which are also these chips that go basically inside everything. They're small, low cost, and are usually connected via Bluetooth and or Wi-Fi, and are really great for using smart building or smart connected projects. So this is just an overview of some of the hardware that we do support. Again, this is so that we can work with people who already have assets on the ground, and we're not trying to essentially have any upfront capital to spend, but to really leverage the existing assets that are there. As mentioned, that PLC is a really great way that we can get information from machines, and ultimately the idea is that we can use the data to better control and automate systems, be it smart lights, smart controls, etc. And so I've just provided here a brief overview of how easy it is to set up systems. It's just a 5-step process. If you wanted to connect a PLC to Kosmos itself, again, the whole setup process is usually under an hour. I can do it in about 30 minutes because I've done it a few times, but what we really, again, strive to do is democratize it. So if you've got the information, we can essentially help you just input it into the software upload itself, and you can have your smart connected product giving you detailed information in minutes, which is really what we're after. And as mentioned, is that predictive maintenance. So this is just a graph that we have about turbidity. Turbidity is usually used as a marker for water quality parameters in a utility that is using a PLC. So this is just something to say that, like, we've taken data over a certain period of time, and through our machine learning algorithms, we're able to say that in the future, we can determine that, in this case, turbidity is going to be exceeding, 70 NTUs, which is a bad threshold, essentially, and be notified or have the on-site managers notified in advance so they can fix the issue. The same exact idea and premise can be used for manufacturing. If you want to know when a machine is going to go down 4 weeks in advance, this is what one of the graphs might look like. So now that we've essentially covered the different aspects of the flexibility of the Kosmos platform with regards to supporting various different types of hardware, and a little bit about the actual data piece, I kind of wanted to go over just the architecture of the Internet of Things, but in the real world. So as mentioned, we have different sensors or machines or SCADA systems that we can collect information from. In this case, I put just a PLC because it's most used in manufacturing settings. that PLC sends information to what we call the gateway. The gateway is a great device. It essentially collects all data from the PLC, and then it enables essentially some analysis to be done here at the Kosmos gateway. It also is great for offline data storage. So if the internet is ever lost, all that data from the machine will be sent and just sit actually physically on this gateway and then uploaded to the dashboard in our cloud once the internet is reestablished. So you never actually lose information. And then also these Cosmos gateways are great because they're about $35 to $45. They have a high computing power, and they're about 2 by 2 inches in dimension. So they're very small. You can essentially put them anywhere. And then again, once the information is collected on the gateway, it then gets sent to Cosmos and/or the dashboard that you see. So this is just the overall IoT architecture. There are different types of architectures, but this is the one that we have designed. It gives us the most flexibility, allows us to essentially support the most amount of hardware, and when we have what we call over-the-air updates, we can essentially push any new features out to the gateway, and the gateway sends it out to the PLC itself. So we've got communication going both ways, again, adapted for innovations that are bound to come when we innovate our system, essentially. So I'm going to talk about quickly just 2 quick use cases just to show the breadth of some of the work that we're doing in the manufacturing sector. So again, the big thing is interoperability, controlling and owning your own data and hardware. So innovating this industrial equipment, we're doing this in the sense of we're looking at water pumps, and we're looking at elevator usage in a huge manufacturing facility. I do want to emphasize that we do not own your data, we don't use your data, and we don't take it or market it to end users. Your data is yours and yours only. There are various ways you can export it and send it to your systems, but the data is yours, and that's something that we did emphasize. All right, let's get into it. So this is a water pump. It essentially is located in a 100-year-old building. It's an old manufacturing building complex with thick cement walls that essentially block any communication. So we had to get creative on this one and think about what's the best way we can tap into this programmable logic controller, or the PLC, to essentially extract the information. And we've essentially done this by plugging into the existing data ports and then transmitting the information over a sub-1 gigahertz radio to our gateways. Now, we use this sub-1 gigahertz radio because it can go through the thick cement walls. Other communication methods like Wi-Fi or Bluetooth would never make it. So we had to get creative again and really figure out what tools we had in our toolbox and are able to essentially get this information from the water pump without asking or having the building managers and our on-site managers add any new capital, which is fantastic. And then we're also looking at, again, in this 100 million or this huge manufacturing building, this elevator usage. So in case we can't collect data directly from their control systems, we're actually adding simple voltage sensors to the elevator floor display panels to read the floor location information. And the reason why we're doing this is because the way that this manufacturing facility is set up is that they charge they charge the tenants based on how many people visit their floor. So this is another good way to get not only consumer behavior, but also it's useful for the actual building manufacturers to know, what the price is going to be, and overall, we're able to figure out if the machine in our elevator was going to be malfunctioning anytime soon. So basically what we've done is, this data acquisition, again, we're using voltage sensors on elevator display panels, and we're connecting to the PLC through Modbus integration with the water pumps. When it comes to connectivity, we're tested a few different ways, but in the basement, because again, the thick cement walls, but we landed on using a sub-1 gigahertz radio in the basement to relay the data to the internet, which is then connected to the gateway. And then we also looked at cost. So we coordinated with the telecom communication to install a cost-effective and shared internet connection. and we relied on existing operational equipment rather than fully integrating and or replacing the actual water pumps and elevator usage, which again makes us more flexible and being cost cautious when we're working with somebody else. And then the maintenance aspect of it. So the operations of the existing equipment doesn't change while we're actually looking at the data itself. Once we do have enough information, again, we'll be using that machine learning algorithm to essentially identify the predictive failure. Yeah. I'm getting some feedback. Ooh, someone has their microphone on. That's okay. I'll take 2 more minutes and just go through one last case study if that works.
Yeah. Sounds good.
Lastly, working with okay, great. So we're working with a major food manufacturer in India and Saudi Arabia. We're working at 14 facilities. This food manufacturer is called Monginis. They make 20,000 cakes per day. They're also delicious and amazing. And really what we want to emphasize here is that we started working with a single engineer who wanted to innovate their system without having to replace anything. And so what we've done is essentially attach voltage sensors to the log alarms in the food scanning system. So anytime anything goes wrong, that alarm goes off, it then is logged in Kosmos, and they're able to not only have the records for their iOS compliance record keeping, but they're also able to be notified and to be able to set rules, etc. And then we're also using proximity sensors and temperature sensors in our cold supplies, which is basically their freezers and refrigerators, to make sure that all of their food is the temperature that it should be, especially if you're consuming it. So that's what we've done with Monginis. Again, it was one person who really wanted to innovate their system, and because of us being hardware agnostic, because we designed the software with the end user in mind, he's able to do it without us having to be there. And he has complete control over the data, and he's just phenomenal. But he's able to essentially start at one facility and then roll it out to the remaining 13 facilities. So again, just a recap, the voltage sensors we put on to existing quality control systems on a production line. These environmental sensors installed in existing refrigerators and freezers. For connectivity, we're actually using the Ethernet connections. For the cost, we relied on existing operational equipment rather than fully replacing it. The maintenance aspect, since the plant engineer was already running the equipment, he already had the updates himself, but he was able to resolve and control all of the issues. Occasionally, he needed a phone call or email support from us, but otherwise, he did it all himself. And then this plant engineer has also gained new skills, which ultimately landed him a new job where he's now in charge of upgrading facilities without having to replace or purchase any new equipment through Internet of Things technology. And then again,
Brianna,
yep.
So
Yes.
I think we have also some questions. I'm also getting some questions on your site. So maybe during the Q&A session, we can continue on your subject as well with the questions that I am receiving in the private box, if that's okay.
Yes. Do you want me to just quickly wrap up?
Yes, please go ahead.
Perfect. So just last 2 slides, and I can send you this information if you'd like later, but just helpful questions to ask when you're implementing an Internet of Things solution in your factory and or manufacturing setting, I should say. These are some questions. Just be very pointed about what you want to monitor, the information you want to acquire, your sensing range, how often you want to view the data, what is your internet connection, your power source, and is your equipment indoors or outdoors? These are questions that we always ask people that we're working with, because again, we like to start small. The idea is that you start small on something that's very specific. And then lastly is also just keep in mind, what kind of data do you need? Do you need live data? Do you need historical data for record or compliance keeping? Do you want analytical for learning and assessing? And then again, that last bit is going to be that predictive maintenance, which is what we're doing with that water tank monitoring in the old manufacturing building and elevator monitoring. And then data for change. the idea would be to have the data actually influence some sort of policy change to essentially make manufacturing, in this case, more accessible. So that would be the ultimate goal. But anyways, I'll wrap up there. There's a lot to cover, but I'm happy to discuss anything further. And there's my email and just some of the places that we work around the world. Thank you.
Thank you, Brianna. Thank you very much. Okay, great. So we learned a lot about the IoT systems and also what Tembu can do for companies who that like to actually adopt digital transformation. So before I hand it over to Sam, I have a couple of slides that I'd like to share with you, and then we'll speed up to user time as efficient as we can, and then we'll continue with other panelists of ours, because we have a lot of subjects to talk about, and these are great subjects that we all like to learn about, and we have limited time. So the good news is this is the digital transformation part 1, and there are other parts will be coming, so we'll have more subjects and hopefully more time to talk about different subjects in the scope of digital transformation. So let's talk about Bimser International a little bit. We are an enterprise software maker since 1998, and we are also based in New York. We are very active in also various regions in the world. We are globally active, and we are working with various ERP systems to supplement them. And we have more than 1,000 customers already globally. What you see on the screen is our core product line, basically. So what we do is we have companies digitally transform themselves. That's what we do. And in this scope, basically, we'll be talking about today predictive maintenance, which will be actually covering B in terms of how to manage equipment, machinery, and how to do predictive maintenance. So it's actually related to what Brianna just mentioned. Basically, Tembu and its technology simply remotely monitor the health of the machinery and equipment. And what we do is basically we pick up the notification from the system, and then we basically help you manage the maintenance operation. That's how we operate. Since we've been around since 1998, and we are very active in enterprise market, we've been working with many different companies, especially in enterprise market and reputable companies. Also, I'd like to also share a couple of information about predictive maintenance in terms of how to manage assets and equipment. So when we look at maintenance management, there are types of maintenance operations. There is corrective maintenance, preventive maintenance, and predictive maintenance. So if something breaks down and if you need to fix it, it becomes a corrective action, corrective maintenance. So there are upsides and downsides of every single type. The ideal one, when we look at it in terms of cost savings as well as operational efficiency and compliance, the best way to go is actually predictive maintenance. So before something breaks down, you take action to make sure that equipment or machinery or device actually keeps working. That is the main idea. Something breaks down, it's much more costly. You cannot make the production. You cannot keep your word to your customers, and it's a big problem, basically. So with the help of predictive maintenance, you basically remotely monitor the health of the machinery with the help of, for example, Tembu. With this kind of remote monitoring systems, basically fits maintenance operations. So when we do basically predictive maintenance, before anything breaks down, we take action. We prepare the crew to make the maintenance operations. We prepare the spare parts, and then also we prepare the machinery equipment, and then based on this plan, we basically take action. That is the ideal way of running things. And when we talk about maintenance, let's remember that maintenance operations brings three things together: man, machine, and material. So these are the important things that we need to be thinking about. In terms of predictive maintenance, everything starts with actually data collection. That is basically, that's typically most of the time the problem. So once you start collecting the data, it is actually a matter of analyzing it and then remotely monitoring the health of the machinery to see the patterns. Basically, based on the patterns, you can basically predict what will be happening to that particular machine from, let's say, a couple of weeks from now. there are various solutions in this sense, just like Brian addressed earlier. Could be about manufacturing, could be about facility management. This that can be a robot basically actually running the manufacturing operation, or could be a simpler machine, or could be an HVAC system or boiler, for example. So with the help of typically wireless sensors or sensors, basically you can collect the data, and that basically they start to collecting the data, and then the rest is basically analyzing the data to decide when to take action and how to take action. When we look at how we can actually implement the predictive maintenance operations or steps of implementation, is first of all, it is important to design the maintenance program. Everything starts with the internal buy-in. So with the inclusion of the team, first of all, it's important to design the maintenance program. And then what kind of technologies will be used for these operations. It also depends on the vertical, depends on the industry you are in, and then how you will be monitoring basically those equipment, simply. Is it the sensors, is it wireless devices, how it's going to be. And then allocating the resources, the team, as well as also making the team available in addition to assigning them. Also coordinating it with preventive maintenance activities is also important. And finally, once everything is actually launched, then you can use all managerial reports as well as dashboards to understand how the program is going and how those particular equipment and machinery is actually running. So that's a very general overview basically of predictive maintenance steps. So what I'll do is I'll hand it over to Sam. So what we'll do is we'll basically show you very high level how actually maintenance operations can be actually run digitally, and then we'll hand it over to our coming panelist. Sam, if you're ready, please take over the screen. Thank you.
Sure. Thank you, Kevin. And thank you for joining this webinar. And this is Sam at Bimser International. So I will get you an overview of our BIM, which is our enterprise asset maintenance facility and energy management system. So this is how it looks like after you log into BIM. So you can find your dashboard and all the widgets. They are movable and they are sizable and modifiable, which means you can add or delete any widgets on this dashboard. And that's why we call it an own design dashboard. So it showed all the real-time data in a table, in a chart, in a pie chart, or in a bar chart. So it showed you all the real-time data, and it's helped you to keep tracking your KPI of your company and also the performance of your companies of different departments or locations. And you can find all the available modules in this main menu, like asset modules for managing the information of your asset, and also maintenance module, material modules as known as spare part module, and the personnel module as known as skill management modules. And by using BIM, so you can have in this asset module, you can have the real Google map, which you can zoom in and out in this map and pinpoint the location of your, for example, like our facilities or plants. And now BIM is taking us to the map. And in this map, also you can find the information or the detail of your facility. And we can also integrate with the GPS that's equipped on your moving asset for maintenance purposes. And now I'm getting back to the map in order to get me into the map. So I need maybe some time in order to get connected from the server. And while we're reading, and you can find also we can create the work request and work order in order to schedule the maintenance activities and manage the material, like the information of the material and the material transactions. Maybe we come back to and we'll get back to the map. But right here, what you can see on the screen is the graphical asset tree. So you can upload your floor plan or the blueprint of your facilities so that you can pinpoint the location of your fixed assets, like the machinery or equipment or the robot arms for manufacturing. So we can pinpoint the location here. And when they're in a green color, which means they're under a good condition, and once they turn into red, which means they are under maintenance operations. And you can move your cursor on this point of the fixed assets and find the details of it, like the code name, department, and location. Okay, and then we go back to the map function. And now you can see right here, which you can zoom in and out in this Google map. And we can pinpoint the location of your fixed asset, and you can find the detail of it, and you can integrate with the GPS that's equipped on your moving assets for maintenance purposes, as I mentioned before. And besides using BIM on the web browser, so that we also have the native mobile application, so you can use BIM on your handheld device like smartphone or tablet. So what you can see on the screen is my Android device. So you can manage your asset information right here in the screen. And you can find the exact same function and data in your web browser and in this mobile application. Or you can create the work request and work order on your handheld device. And this is my demonstration. Thank you, Kevin, and thank you everyone for your time.
Thank you very much, Sam. I appreciate it. Thank you for the insights. So we talk about IoT technologies in terms of remotely monitoring systems with the help of wireless devices, for example, sensors. And then we also talk about predictive maintenance. So we remotely monitor it, and then we take action to basically maintain any device that we may have. That may be a facility, that may be an equipment, machinery. So these, as you see, these technologies are actually linked to each other. Actually, they are integrated with each other in one way or another. Thank you very much, Sam. We appreciate it. So let's continue with our next subject, Microsoft Dynamics ERP technology. So I'd like to hand it over to Umut Altınay, and Umut will basically show us what kind of technology is available from Microsoft in the scope of digital transformation if you'd like to have an ERP system. Umut, if you're ready, please share your screen. Thank you very much.
Hi, Kevin. Thank you.
Thank you, Umut. Whenever you are ready.
Okay.
Looks good.
Thanks for having me. Okay. I would like to start with my last slide of the presentation. So thank you for coming for this webinar. And my name is Umut. I'm working as a business development manager at ETG Consulting. I have just one slide for ETG Consulting. We do Microsoft Dynamics ERP business for 20 years, and our office is in US, in New York, and which is I'm based in also in New York, and office in Atlanta, Georgia, at the West Coast and Midwest, and we have office in Vancouver City in Canada at the West Coast. And we have also offices in UK, I mean in London and Istanbul for our European and Middle East operations. So we basically focus to 3 industries as a company. First is manufacturing. We also focusing to retail business, and healthcare is our third focused in the industry. We are top level of Microsoft partner, which means inner circle, which means the globally first percentage of the Microsoft Dynamics partners. So this is all about ETG Consulting. We are very focused ERP company and Microsoft partner for almost 20 years. So this is my first slide. So digital disruption is forcing every company and industry to rethink themselves. A huge part of this transition is about reinventing how businesses engage with their customers and their business processes, and how they take advantage of the data and intelligence. And manufacturing is truly innovating with streamlined production and connected products. So the world that we live in today is fast and ever evolving, because our products now designed to be directly connected to customers, like Apple Watch and like the Tesla car. They are creating an always-on connection that gives us real-time insights. So it's about being able to reason over this data. So this is why data has become the new currency for organizations. Industries must take on a strategy that connects their customers, their employees, products, and operations as effectively as possible, and connected business application strategy and implementation can support industries that are looking to disrupt. This framework we call digital feedback loop, and the framework we use to highlight how digital transformation is enabled, and at the center is, of course, data. Every single product at this point has ability to collect data. For example, my thermostat at my house, or every motors that manufacturing, like Brianna mentioned, they always, ability to collect data, and this information allows us to better understand our customers, our operations, which then allows us to go mine for intelligence, predict what customers may need, and taking all this information, these predictions which Kevin mentioned, and then feeding that back into your business processes. This is where the change is occurring. So this digital feedback loop concept across your core business processes is ultimately what allows you to go transform, to change your business, to change your processes, and ultimately to transform your industry, actually. It is what Microsoft doing across Office 365, Microsoft 365, LinkedIn, Azure, Dynamics 365, and the Power Platform that uniquely comes together that make it possible to enable digital transformation for Microsoft customers in a way that I think no other company provides for. Let's deep dive into Dynamics 365. To execute on our strategy, Microsoft created a unique data system, and it removes the complexity of systems, and it's bringing ERP and CRM, I mean customer relationship management, together instead of silos. This fundamental technology shift set the foundation for Dynamics 365, an engine of intelligent applications that connect customers, products, people, and data, and help us break down silos. This includes, marketing, services, sales, operations, which includes the manufacturing, finance, and the talent, HR capabilities. And these products are infused with data and intelligence, connecting the Dynamics 365 applications with Power BI, Flow, and Power Apps. Together, these products compose our modern, unified, intelligent, and adaptable product line. By modern, we mean is mobile. You can see here for Microsoft Dynamics 365 ERPs, the power of the Microsoft Cloud and Azure is the core. And the top of that layer you can see the lifecycle services which continues life to your system, your software, and you can manage your business processes here. And above this layer, there is proven business logics like the modules of the ERP, and of course at the top level, intelligent user interface, Power BIs, and the other managerial reports. And Dynamics 365 ERP has, key differentiations and intelligent insight. This is the turning data into actionable intelligence. So you can see the core product priorities under the finance, manufacturing, supply chain, and the retail sections. So, and right-hand side, productive experience means engage and empowered employees on the strength of productivity, even user experience and business processes, and of course the mobility. Mobility is the one of the key function and key differentiation for Microsoft ERP solutions. And the power of cloud. This is customer in control and business agility, scale with your business, and familiar developer tools to your technical developers and IT guys. So this is all includes in power of cloud section. And the business anytime, anywhere means mobilize your work, simply powerful, cloud-powered, compliance and intelligent cloud. So at the core of everything we do is to empower our customers to reimagine their businesses and grow at their own pace. Thus, we are giving customers the choice, choice and flexibility to select the deployment scenario that makes sense now, but also have the flexibility to change later with choices ranging from full cloud to cloud and edge to cloud business data. You can move in either direction depending on your business needs. And cloud deployments provide a cloud service that is easy to scale up or down as needed, as well as data centers that are fully managed by Microsoft. And the time spent implementing Microsoft ERP can be significantly shortened and fewer customization may be required, and the cost of IT hardware and infrastructure are lower. Cloud deployments include high availability, disaster recovery, sandbox environments, and application lifecycle management combined with cloud-based system of intelligence, infrastructure, compute, and database services in a single offering. Microsoft takes seriously and our commitment to safeguard to customers' data to protect their right to make decisions about that data, and to be transparent about what happens to that data. And we are guided by a set of trusted cloud principles that articulate our vision of what enterprise organizations are entitled to expect from their cloud provider. We mean social data connected to inform interactions and strengthen relationships, and with virtual and mixed reality, which the panelists after me will tell about more, that mixed reality and augmented reality or other virtual reality technologies. And Microsoft reshape the digital fabric or business. And with modularity, we enable customers to choose their own transformation pathway, and all of our applications are unified. This is one of the important things. At the end of the day, it's data that makes the unification possible. But it's not just Dynamics 365 ERP or CRM side. also Office 365 data and related to your structured business processes data too. So your unstructured communication, collaboration, creativity processes also relate into the structured business process data. And you can understand how many meetings did you have with this particular opportunity that you are managing in the sales module, for example. But it doesn't stop with your data. LinkedIn now, is part of Microsoft. We also pull that data into this connected underlying data substrate. So now you are bringing signal not from your property systems, but from the social network, and understanding that this open opportunity is actually someone that knows someone that you know. And this is an open platform, and so bringing in all of our in our systems and allowing this data to collect in order to create intelligence ultimately, and then value as delivered through digitally transformed business processes. Yeah, with the machine learning is also part of these technologies. And Microsoft App Source, you can reach to Microsoft App Source, appsource.microsoft.com. This is the Microsoft marketplace, business marketplace, and it's rapidly growing. We have got over 6,000 applications for now, and over 2,000 ISV companies of Microsoft partners like ETG Consulting, and 1,400 plus specific ERP and applications published on App Source. As ETG Consulting, we also published 6 of our solutions to App Source, and in the very beginning of the next year, I hope we're gonna publish one of our mutual product for with Bimser, which is QDMS. This is the solution for the quality management. So we're gonna put our QDMS solution for Dynamics 365 on to the App Source in next couple months. And next, last year in September 2018, Nucleus Research recognized the Dynamics 365 ERP solution as a leader in ERP section. So customers are very interested in Dynamics 365 with 60% year-over-year increase in Gartner ERP inquiries. So this reaction of the press is also similar. I can easily say that the customers interested in Dynamics 365 are increasing. Yeah, this is the key impact of the what customers saying about the value of the Microsoft ERP. But I know I reached the end of my time, so I just want to see few customers from international, from USA, Umbra Group. They are using Microsoft ERP, and Maersk, one of the biggest sea lines, they use Microsoft ERP, and Chemonix and Renault Sport team for Formula One team, and Mattress Firm, and Accuvator, Beerwolf, Hagler Systems, and Coipa Solar. These are all use Microsoft ERP, Microsoft Dynamics 365 ERP. And thank you for your time, and thank you, Kevin, for having me for this great webinar.
Thank you very much.
If any questions, I appreciate to answer.
Thank you very much, Umut, for the great insights about ERP systems of Microsoft. Much appreciated. So let's continue with our next subject, AR and VR technologies. So what we'll do is we'll hand it over to VR Masters, Ali Hantal from VR Masters. Ali, if you are ready, we can give you the screen. So as a reminder, we keep our email addresses on the screen, as I mentioned earlier. And right after Ali's presentation, we'll have a Q&A session, and we'll be addressing your questions. So please feel free to type your questions in the chat box, or you can just type it to me, and we'll be addressing your questions. Ali, whenever you're ready, let's see if...
I am ready, and...
Okay, great.
I share screen.
1 second.
Yes.
You got it. Thank you.
Yeah.
We can see your screen. Looks good.
Perfect. Hello, everyone, and welcome to the part 1 of this webinar. Let me briefly provide you with information about who we are. VR Masters is a team that consists of spatial computing engineers. That means augmented reality. But when you combine it with artificial intelligence developers, computer vision experts, and talented 3D visual effect artists, that makes actually spatial computing and mixed reality technology possible. We create digital twins of both indoor and outdoor spaces, and we provide the most accurate augmented reality alignment that's without drift between the intelligence to be visualized and the actual physical world that it will be superimposed onto. I will actually get into detail about use cases, and you will see and get a better understanding of it. Our solutions support your manufacturing, maintenance, training, and after-sales processes, and help you to increase efficiency by lowering training times, reducing error rates, and cutting expert travel times. In the next slide, you will see that we have spatial data visualization solutions for your BI analytics, field asset management, manufacturing, marketing and sales, and after-sales processes. We are the top mixed reality partner of Microsoft in Turkey, and we actually have offices in Turkey as well as in the US. We're based in Chicago in the US, and we also partner with Silicon Valley partner. We have a partner there for research and development, and I go to Valley a lot for that meetings. And we are always, let me see what's going on with the slides going on its own. Okay, I had to pause it. We are creating data. We provide spatial data visualization, and this is one of fairs and conventions that we attended in Ankara. And we are here exhibiting our Dash Room solution, which actually is a dashboard making a room, any space for your data to be superimposed onto, and that provides a lot better understanding. Now, if we look, we also had a partnership with IBM, and we worked together to develop a mixed reality version of IBM QRadar Pulse security solution, which I'll be showing you a short video of in the use cases section at the end. We also worked with Ernst & Young closely to provide a solution for one of their solution partners and manufacturing company who actually is manufacturer of refrigerator, industrial level refrigerator. I'll be also showing a short video of that as well. These are the other brands that we have worked with. So I am excited to talk to you about approaching the new spatial web revolution. That's also called mixed reality revolution, and the implications of how we do business. We believe the convergence of the technologies that you are seeing on the screen, mixed reality, spatial computing, 5G, artificial intelligence, IoT and sensors, as you listened earlier, and computer vision is opening the way for a new revolution where the world around us will become the actual canvas for content creation. Soon, we will experience 3D content and holograms presenting live data on this new canvas, which will eventually bring the 30-year-old two-dimensional Windows interface to an end. So spatial web, or as some else call Web 3.0, will soon replace the current internet, and AR tablets and AR headsets will also replace existing mobile phones, tablets, and computer screens. We are about to take a giant leap forward in the way we use the internet and how we interact with each other, how we train our teams or educate our kids, and how we do business will change dramatically in the coming decade. Spatial technologies are in the hearts of this, and we believe spatial technologies will integrate the real world with the virtual one, and it could actually be the glue that can hold today's different technologies that we talked today about: ERP, IoT, computer vision, asset management, all of that. The spatial technologies will be the glue that will hold all of those together. Before proceeding forward, I would like to touch upon a question that we receive a lot. That is, what is AR and what is VR? When you come to VR, it's simply a computer-generated simulated environment where the user is disconnected with the real world. We call that the screen becomes your world. So you're not connected with the outside world anymore. You are on a different world, a dream world, and you could be flying, you could be against the physical world's physical rules, or you can have a different body than yours. That's virtual reality. If you look at augmented reality, that's when the digital content is overlaid over the real world. The user is still aware of his or her surroundings. In this case, the lady over there is seeing a visualized hologram, and that's when the world becomes your screen. Remember, VR was the screen becomes your world, and augmented reality is where the world becomes your screen. How about mixed reality? Mixed reality is a little bit more than AR. It's blending of the physical and the digital worlds, and it actually means that holograms are actually on your physical world, and the headset or the tablet or mobile device that you're looking the world with knows where actually everything around you is. That could be a furniture, that could be an asset on the field, or a CNC machine that you are about to do a maintenance work on. This content with mixed reality, when you talk about mixed reality content, we are talking about a content with the context, format, and collaboration that make it most relevant to you. When we say context, we're talking about how mixed reality helps you overlay 3D graphics and data callouts inside the model you're building or the room you're in. The format is the mode of delivery, not an architectural blueprint to show the dimensions of a house or what it should look like, but a 3D model of it. And that model can even be reproduced to scale. So you can visualize the giant engine part in its actual size. The format changes dramatically when you have these digital models. You can layer on top of physical ones, and so does the collaborative experience. You can call the people you're collaborating with. No more screen sharing anymore. You're actually sharing a space. I can see what you see, and I can actually annotate on what you see if you are on the field and I am the expert. So when you're doing remote monitoring and things like that, instead of having to have the experts on site, you can project the vision back to people, all with built-in video conferencing communication. So those are the 3 dimensions: pulling in the right context, using the format that makes sense, and working with the people who are going to provide the most value. These are 2 of the mixed reality glasses or spatial computing glasses that you can find. HoloLens 2, which just is launched, and we heard about Alex Kipman and Nadia, CEO of Microsoft, talk about that last February. HoloLens 1 was out about 3.5 years ago. and then we have seen Magic Leap, which came for mostly consumer market, and we have had extensive experience on working with HoloLens 1, and then we're very excited about HoloLens 2 because after 3.5 years of experience and learning, Microsoft has done an amazing job, and we are very excited to work with that as well. Let's look at the digital transformation side of it. Mixed reality is a core component of digital transformation. Digital transformation brings together the relationship of these three concepts: reinvent productivity and business processes, build the intelligent cloud platform, and create more personal computing. Mixed reality platforms and devices are key drivers of each of these elements. Let's take a moment to look at the current state of the industries that first-line task workers operate in on a day-to-day basis. The workforce is changing, and in many countries, there is a shortage between the number of available skilled workers and technicians to get the job done. For manufacturing positions in the United States alone, 25% of American workers will reach retirement age in next 2 years. 3.5 million jobs will be created over the next decade, with only half of those jobs getting filled. And 60% of open skill production positions are going unfilled due to talent shortages in the next decade. For many companies impacted by these labor shortages, there is a strong demand and need to arm new employees with the tools, expertise, and skill sets necessary for being successful. And with technology advancing so rapidly, work has become increasingly complex. In many cases, technicians are spending 65 to 75% of their labor on non-wrench time, either learning a new skill or gathering information to perform their assigned tasks effectively. In many cases, an assembly process can change every 5 minutes, making the task at hand even more challenging. But despite the modern advancements with this technology, many companies are training employees with outdated methodologies or depend on new employees to learn from 2D documents and assets on their own. The traditional classroom and online learning approaches may work for some employees, but don't allow the first-line worker to experience learning and training in context with their environment, especially when humans tend to forget 80%, yes, 80% of what they learn after only 30 days. With the increase of skilled labor shortages, challenging environments for field service technicians, and lack of updated or relevant training materials, there is a clear need for the first-line worker to evolve the way they learn and experience training in context. At its core, power of mixed reality comes as very essential and fits in. It grows out of the way humans process information. We access information through each of our 5 senses, but at different rates. Vision provides us with the most information by far, an estimated of 80%, sometimes 90% of the information humans get is accessed through vision. Because it improves our contextual awareness, because mixed reality does improve our contextual awareness, as we explained, by blending the real and digital worlds, this technology poses the potential to unlock human productivity to previously unimaginable new heights. What mixed reality or augmented reality does for these powerful technologies will essentially be providing a way for users to interact with technology as if it were actually present in the real world. From manufacturing, retail, and government to healthcare, education, and financial services, this slide shows you the business applications of mixed reality. What we call a self-assist and train employees with instructions in physical context of their work. So we are now, for the first time, providing self-assistance, electronic assistance that the technicians on the field will be able to receive. Remote assistance, we will be having videos on that as well. Space planning, collaboration, and we call also holoportation, and spatial business intelligence and analytics that I showed you earlier as Dash Room. Here are how I will then be going to use cases, and let me, okay, it doesn't want to be staying there again. Mixed reality will revolutionize many business processes, and the end result, what we have already experienced, is increased efficiency, including improved first-time fix rates, so lowering human-based errors, less downtime, lower expert travel costs, improved client-facing interactions, drive better remote access processes, improved knowledge transfer between seasoned and new employees, which is one of the major problems. And if anyone is retiring now, there's a statistics that says that 40 years of knowledge is being lost with that person if that person has been in the same job for that long. Faster learning curve for trainees and increased safety. Now I'll be showing you short use cases and then checking my time. Are we about to have questions and answers? I'm going to show you very few videos and then we'll be done. Here's a remote assist example where you can see that the person on the field is receiving a remote help from that person she's just calling to. As you can see, what she's seeing, the field service member is seeing a holographic screen, and the person at her office can see what the field team member is seeing, and not only see, but also annotate on her scene and send her screens or other files, pictures. And if you can see, she just pointed out that she should get the flyers open and reach the panel there. So that she actually annotated real time. That's one of the great parts about how experts will be helping remotely team members on the field. Another example is a predictive and prescriptive maintenance part. Actually, Kevin talked about this as well as Sam did, and if you can see, this is a use case we have worked with manufacturing, refrigerator cabinet manufacturing company. And here you can see that on the left of the asset, you can see holographic information about next scheduled time and maintenance records, model of the demo model, what you're seeing, and two-dimensional pages as PDF, holographically standing right next to the asset. Actually, on the shelves here, if you look, you can see sensory-based data that is coming real-time to HoloLens that the person on the field is right now wearing. If you continue a little bit, you can see that on the right side, you have of the cabinet, you have the energy consumption graph, carbon emission graph, all these data coming from the actual asset. And there's also temperature and humidity on the shelf spaces that you can see. Now, I would like to show you a good showcase about a good use case about how, if there's predictive maintenance installed in the system, that visualization would change from two-dimensional to three-dimensional. We're no more trapped in the 2D screens or tablets. So if you look at here, there's a warning coming from this machine. It says overheating and there is error predicted in 2 hours. So in this use case, we just said, let's change the compressor. So self-assist program, which is the prescribed program, was started by clicking on next, and now the headset is providing step-by-step instructions on how to go. Please remove the left shelf, please remove the right shelf, and then if you go at the end, remove the compressor out, and this is how you just, if that was the prescribed maintenance, it's how you would be doing that. And on-asset self-assist is another good example to show you, is this one. Here, we like this example a lot because the instruction, as you can see, follows the field member. See, right there, it actually follows the team member and provides her with the right thing to do, how to use the tools, and where actually you'll see on the next screen that where actually put that part installed that she's holding in her hand. Basically training, and all of self-assist will be changing a lot in how we do business in our day-to-day lives. Here is another example that I'm going to show you shortly. And there is also another way of doing this, is not on the asset. So if you look, you can actually work and collaborate remotely. You don't even have to be in the same office anymore. And you can work on a digital twin of an asset or a space. And this is going to also make things very easy to work on and collaborate on. Here is an example of that for you. This is holoportation. As you can see, not everybody is in the same space, but they are sharing the space, not screens anymore, and they're sharing the digital twin that digital twin of the space or the engine that they're working on. Final example that I would like to show you is a very exciting example for us. We worked with my IBM, as I told you earlier. This app is IBM's QRadar Pulse application, one of the screens on the security platform. And the app allows you to visualize your offense data when you're under a hack attack, associate offense areas geographically, and flows in 3D images. Visualize your offenses in real time, near real time. So this was the screen, two-dimensional screen, but you see where the attacks are originating from. What we have done, and this was actually exhibited at my IBM's Security Summit, IBM's Think Summit, was this. We basically created a 3D hologram of that same globe, and we exhibited this. It shows the real-time data as it is flowing, and basically now, instead of seeing it on a two-dimensional screen, you are seeing it on a three-dimensional screen. Coming to my conclusion, we believe we're at very exciting times, and visualization is going to change dramatically. The way we do things, the way we collaborate, as I showed you here, is going to change dramatically. And we are very excited to work with especially these type of companies, IoT, ERP, asset management companies, when it comes to visualization, visualizing the intelligence, visualizing the data that is available to us. Thank you very much. And here is my information. You can email me at ali.hantal@wearemasters.com. Thank you very much, Kevin.
Thank you, Ali. I appreciate it. It was actually very, very insightful, very helpful for us. We learned a lot. Much appreciated. We learned from all of our panelists, actually. So that's our Q&A session. We are actually pushing the time limits of our webinar, which is good. There are many things to talk about. And as I mentioned earlier, we keep our contact information on the screen. So if you like to ask questions later on, if you like to have meetings later on, continue this conversation, you can contact us via email. Our contact information is on the screen. So I have a bunch of questions actually I've been receiving from the attendees, and many things to talk about. So what we'll do is I'll ask some of them, I'll share with you. If you can address, that'd be great. And then also, as I mentioned, we have the contact information on the screen, and we can talk to our panelists after this webinar as well. Let's remember that this is the part one of digital transformation. There are many things to talk about. This is technology, and pretty much anything is possible. But the idea is that how we can adopt technologies in our business in an economically sensible way, in terms of how we can make our operations, basically how we can improve them by using the modern technologies. So we need to think different. We need to look at it from different angles. So what we are trying to do today is we have been sharing information with you in terms of digital transformation and what kind of technologies are available for different industries. You basically make the analysis, and if you like to ask more questions, of course, we are all of us here to help. So let's see what we have in terms of questions. One of the questions that I got actually is about Beam, about predictive maintenance. Is Beam able to run on-premise servers as well as cloud? That I can answer yes. Beam Enterprise Asset and Maintenance Management System is ready to run on cloud as well as on-premise servers. So that's a pretty modern technology for predictive and preventive maintenance. One of the questions that I got actually, I think it is about Tambul. Brianna, I'd like to share with you. Is the gateway necessary to collect the data remotely?
Yeah, so we have the gateway situated in between the sensor or PLC, in between our cloud service. And we do that because, as mentioned, the over-the-air updates. So we send out updates, new features that we have to Kosmos. We have new updates about once every 2 weeks. Every update that we get, we send out to the gateway, and that sends that new feature out to the sensor. So the gateway is necessary for, again, over-the-air updates. And also is another security protocol. So a lot of people don't necessarily like to have their PLCs connected directly to the cloud service, which is totally fine. So we have that gateway also just as an added security feature. And one last thing on security, since I brought it up, all of your data is encrypted from the moment it leaves the sensor to the gateway and from the gateway to the cloud.
Thank you, Brianna. Yes, I'm glad that you also mentioned security, which is very important nowadays, that we have been talking about cybersecurity, how we can make our systems safer for users, for businesses. Another question, actually, before I like to share other questions with other panelists, is the data mined when you collect the data with, let's say, Kosmos, for example?
By mined, it's more or less, I'm not sure what you mean by mined, but it is collected from the sensors or existing SCADA systems. So, for example, that PLC is doing whatever function. Maybe it's producing 200 springs a minute or something. It's designed to take in a piece of metal, cut it, and it's very supply chain oriented. In that PLC is other ports that we can connect to that allow us to essentially communicate with it. And that communication is between RTU and Modbus, which is irrelevant for this question, but it is, whether we mine it, it's more or less we just collect the information already sitting on the PLC.
Okay, I understand. In terms of connection, is it Wi-Fi, is it cellular, how is the protocol?
Yeah, so we work with a bunch of different communication protocols. So that sub 1 gigahertz is ideal for manufacturing factories due to just the structural build of many manufacturing facilities. We also work with Wi-Fi, cellular, Bluetooth, and those are probably the main ways. So we've got a lot of flexibility, and of course, we have a lot of flexibility between communication protocols, i.e. how we connect the gateway to us. And we can also do direct Ethernet port connection as well.
Great, thank you very much, Brianna. Ellie, one of the questions that I have is about HoloLens. So in terms of HoloLens 2, they have started to ship it out yet or not yet?
Yeah, HoloLens 2, about a month ago, started to ship for only enterprise clients, but then they had really huge demand coming out, and we are right now talking on a daily basis. And as soon as they replenish their inventory, they are going to start shipping those pre-orders that have been done in the last year. So they are currently on hold for a while, but it'll start as soon as the inventories are replenished, which are expected to be anytime within the next month.
Sounds good. Thank you very much, Ali. Another question that I'll share with Umut before we end our webinar is so in terms of ERP systems, there are many different actually parts of an ERP system. I mean, in addition to accounting and finance as we know it, there are different functionalities. So I get a couple of questions, so I'll just ask you as a mix, and then you can basically address them if that's possible, Umut. So can you tell us about the vendor management as well as product configuration capabilities in terms of Microsoft ERP system that you were referring to during your presentation?
Yeah, sure. You can collaborate with external vendors using a vendor collaboration interface that displays information about like purchase order or invoices and the vendor's stock. And you can easily set up a workflow to provision new interface users to manage their security roles. And also you can use the vendor collaboration mobile workspace to help vendors stay informed on purchase order status and respond easily to orders, that are awaiting approval. So yeah, lastly, I can mention that and you can retain records of all collaboration actions for vendor performance evaluations and auditing purposes. So in Microsoft ERP Dynamics 365, the vendor management is one of the main functionalities. I can easily say that. And what was the other question, Kevin? Sorry.
It was also about the warehouse management.
Warehouse management.
Correct.
Sure. You can manage warehouse processes for manufacturing, distribution, and of course for the retail companies. And you can also get out of the box and next generation support for barcode scanners, which includes that barcode application, mobile applications comes with the Microsoft ERP as an app. And yeah, you can integrate warehouse management with other business processes such as transportation, manufacturing, quality control, or purchasing, sales, and returns. Yeah, advanced warehouse management functionalities, again, the core functions of the Microsoft Dynamics 365 ERP.
Thank you very much, Umut. So before we end our conversation, let's let our panelists, if you'd like to share your final notes. Brianna, before we end it, would you like to share anything else with our attendees and listeners?
Again, what we really strive to do is make sure that anybody can access a smart connected system despite educational backgrounds. And so that's really important to us, and that's why we've taken the best user-face experiences and made it into one platform, which is what I showed you guys earlier today. So if there are manufacturing kind of hurdles that you'd like to get over with regards to Internet of Things, we're always up for a challenge, be it connecting a water system in a 1 million square foot building with the concrete walls, or working around the world with a single engineer. There's a way that we can make a smart connected system happen, and we're happy to always address any of the challenges. So if you'd like to discuss further, I'm happy to do that. And thank you for having me, Kevin, and everyone else on the panel.
Thank you, Brianna. Sam, would you like to share any notes while we are ending our webinar?
Sure. Thank you, Kevin. And thank you, everyone, for joining this webinar. And this is my great pleasure to share our product BIM with you. So if you have any questions regarding our products, feel free to email me or call me. So you can find my contact on this page. Thank you, Kevin, and thank you, everyone, again.
Thank you, Sam. Umut?
Thank you, Kevin, for this great webinar, and thanks for having me. I don't have any specific topic for right now, but thank you all this great webinar. Thank you.
Thank you, Umut. So among us, I believe Ali was the only one who was actually from Chicago today. So Ali, if you'd like to share any final notes before our webinar is over, please.
From Central Time, you mean? Okay. Yeah, I would like to just share this. What I discussed in 15 minutes, maybe a little bit more, is a very complex technology that it's not very easily understood. So if anyone is here for more questions or would like to learn more, they can always email me as I can put it again, it's ali.hantal right there. You have it on my email. I would be glad to have a one-on-one session and go over their needs and understand the need and then provide the right solution, which might not always be an augmented reality solution, could be a virtual reality solution. So these technologies differ from need to need. You know, we have the ability to work with every platform, and we are ready to help any person, any company, any organization who are in need of these technologies. Thank you very much for the webinar again, Kevin.
Thank you, Ali. I'd like to thank our panelists. Thank you very much for sharing your insights and your expertise. We learned a lot, and we all know that there are many things that we need to learn in terms of digital transformation. So that's a journey. That's how we look at it. So we are in this journey, and I appreciate your insights. I'd like to also thank our attendees. Thank you for your time, and thank you for your interest. As we all mentioned earlier, this is the part 1 of digital transformation series as webinar. So we look forward to seeing you in our coming webinar series. I believe it's going to be in the first quarter of next year. And I would like to wish everyone happy holidays. Thank you, and have a nice day.